Next, we will talk about Spark streaming. After this video, you will be able to summarize how Spark reads streaming data, list several sources of streaming data supported by Spark, and describe Spark sliding windows. Spark streaming provides scalable processing for real-time data and runs on top of Spark Core. Continuous data streams are converted or grouped into discrete RDDs, which can then be processed in parallel. Spark streaming provides APIs for Scala, Java, and Python, like other Spark products. Spark streaming can read data from many different types of resources, including Kafka and Flume. Kafka is a high-throughput publish-subscribe messaging system, and Flume collects and aggregates log data. Spark streaming can also read from batch input data sources, such as HDFS, S3, and many other NoSQL databases. Additionally, Spark streaming can read directly from Twitter raw TCP sockets and many other data sources that are real-time data providers. So how does it all work? Here, we show you a flow of transformations and actions, which you will try in the upcoming reading and hands-on exercises on Spark streaming. Spark streaming reads streaming data and converts it into micro batches, which we call D-streams, which is short for discretized stream. In this example, a 10-second stream gets converted into 5 RDDs using a batch length of 2 seconds. Similar to other RDDs, transformations such as map, reduce, and filter can be applied to these streams. These streams can be aggregated into windows, allowing you to apply computations on sliding window of data. In this example, the window size is 4 seconds, and the sliding interval is 2 seconds. In summary, Spark streaming is Spark's library to work with streaming data in near real time. These streams can be used just like any other RDD and can go through the same transformation as batch datasets. These streams can create a sliding window to perform calculations on a window of time.